Good evening, my students who are in class 12. So today I have come to make you understand before your exam the principle of compound microscope. So ये जो कंपाउंड माइक्रोस्कोप है, इस कंपाउंड माइक्रोस्कोप को जानने से पहले हमें ये साइंटिस्ट He is Zacharias Janssen, already we have come to know from the earlier video. During 1590, he has given a lens, and also he is called a lens maker. He has given us the idea of magnifying lens, or we can say it is a simple microscope. Also, he has given the idea and proposed compound microscope. In compound microscope, the main theme is that two convex lens has been taken, in which one is said to be objective lens and another is said to be eye lens. Both are convex lens, but the object lens which is taken as with a smaller focal length and with a smaller aperture, and the eye lens, which is also a convex lens, has been taken as a smaller focal length and a larger aperture. The main principle in this that already we have learned, हमें पढ़ चुके हैं क्लास 10वीं कक्षा में लेंस के बारे में भी हमने पढ़ चुके हैं, जिसमें कॉन्केव लेंस भी होता है, कॉन्वेक्स लेंस भी होता है, उनके बारे में हम ऑलरेडी पढ़ चुके हैं. तो कॉन्वेक्स लेंस में क्या होता है, जब कोई ऑब्जेक्ट फोकस के पीछे रखा जाता है तो उस ऑब्जेक्ट का जो रियल इन्वर्टेड इमेज और मैग्नीफाइड इमेज बनता है वो लेंस के सामने बनता है और बियॉन्ड 2f बनता है. बस इसी को ध्यान में रखते हुए जब ये इमेज जो बनता है, इस इमेज को हम आई लेंस के साथ एडजस्ट करते हैं और इस इमेज आई लेंस के लिए बन जाता है ऑब्जेक्ट, और फिर अच्छी तरह से एडजस्ट करने के बाद हमें एक वर्चुअल इमेज बनता है, वही आई लेंस के द्वारा. तो यही है मेन मैकेनिज्म. सो अब हम पढ़ेंगे कि मैग्नीफाइंग पावर किस तरह से किया जाता है, निकाला जाता है, डेरिवेशन किया जाता है. चलो अब हम देखते हैं. So already I have made you to understand how to find out the compound microscope. In compound microscope, the two convex lens are put coaxially at the two ends of the tube. Now here, this is the object lens, because object is kept over here. It is of a shorter aperture and a shorter focal length. So this is object. So from here to here, it is object distance. We can write down here like this. And this object is placed just beyond the focal length, so that the image formed on the other side is beyond 2f. That means we are getting the image of AB over here, A dash B dash, which is inverted. So here from this portion to this portion we can find it out. This is the image distance. Now the image formed by the object lens is A dash B dash. This A dash B dash becomes the object for the eye lens. This is eye lens, which is of a larger aperture and a shorter focal length. Now this image which is formed due to object lens is between the focal length and the optical center of the eye lens. Now the object here is adjusted so that the final image, that is the virtual image formed by this, is A double dash B double dash, is at least distinct of distant vision, because we have to adjust the object in such a manner that the image we get from here is the least distance of distance at this distance. Now considering the object height is this, so taking the object height over here in the same pattern and subtending an angle at here. So what we are getting, let this angle be alpha and let the angle subtended by the final virtual image be beta. Now, according to magnifying power, we have already learned in the earlier classes that it is the ratio of the angle subtended by the final image. This is the final image at the eye with to the angle subtended by the object when seen through the eyes kept at a least distant of distinct vision. We have taken an object over here as a placed at the least distance of distinct vision. So from here we can write down as m is equals to beta by alpha. Since beta and alpha are such a small angles, so which can be considered as tan beta by tan alpha. Now from this diagram we can say that tan beta is subtended from here, so we can say that tan beta is equals to a double dash b double dash by a double dash c dash. So instead of tan beta we can write it here a double dash b double dash divided by a double dash c dash. Again tan alpha, from this we can take tan alpha as, let us say this is q, we can take as a double dash q by a double dash c dash. Again we can see that a double dash q means it is AB. So instead of a double dash q we can write here AB and this gets cancelled off. So finally we get a double dash b double dash by, instead of a double dash q, instead of this we can write this, that is AB. Now on multiplying the numerator and the denominator with a dash b dash, so this can be rearranged as if in the form of like this. We can write here a double dash b double dash, see a double dash b double dash is the image, okay. So this by we can write as a dash, this is b dash by a dash b dash into a dash b dash by AB. See, just I have rearranged this. Why? Because now you can see that a double dash b double dash, that is a double dash b double dash is the image formed by this, by a dash b dash. A dash b dash becomes the object of this lens. That means we can write it here as ME, if we, that is magnifying due to eye lens, into again a dash b dash. A dash b dash is the image formed due to object lens, so divided by AB, that means we can write down it as MO. So already the signs we have known in this. So till last we got this has to be magnification due to eye lens is this and magnification due to object lens is this. And also we know that the magnification due to object lens can also be written as the image distance by the object distance, and magnification due to eye lens can be written as image distance by object distance due to eye lens. Now from here we have already defined a lens formula, that is 1 by Fe, that is due to the eye lens, is equals to 1 by Ve of the eye lens minus 1 by Ue. Now multiplying and dividing both sides with Ve, so finally we get this. If it gets cancelled out and becomes 1, let us bring this minus Ve this side, so it becomes minus plus Ve by Ue is equals to 1 minus VE by FE. Now since VE by UE already we know that it is ME, so instead of this we can write it here, which this can be written as ME is equals to 1 minus VE by FE. See here, now applying the new Cartesian sign, the VE is kept at least distant of distinct vision, which is taken to be the negative. So negative of negative becomes positive. So we can write here as 1 plus D by FE. So this is a magnification due to eye lens, and magnification due to object lens also we have got it. So finally what we get the magnifying power, just now we have read it as M is equals to, earlier we have got this, now M naught can be written as this. We know that when due to magnification of object lens into MAB, which we got this. So this formula is very important for the magnifying power of a compound microscope.